Good morning, this is Dr. Polaiah, working as a professor in the Department of IT, Institute of Aeronautical Engineering, Hyderabad. So I'm very glad to inform you all about our today lecture, that is video lecture, which is the complete one of the important topic, that is basics of full color image in smoothing and sharpening. The topic which we are selected for the sake of the subject which we are in the continuation of delivering the lectures from the image processing. Okay, so this image processing help us to understand one of the topic, that basics of full color image in smoothing and sharpening. Let me go through the in detail about each and every concept. So see here, I want to define how to understand the smoothing and the sharpening of an image processing. So here you already knows, you are all aware about color image, how we are taking an color image, either 2D or 3D image, either 2D or 3D image. Being it is a color image, which we are going to be keeping in terms of your required manner, in the sense to make this image into your application, application in the sense your target image. So your target image which you are going to keep, for that we wanted to understand how this target image can be prepared, how it can be applied. So for that we are using our smoothing and sharpening of image process. Say here we are taking color image. Obviously we are taking color image smoothing is a part of pre-processing techniques intended for removing possible image perturbations without losing image information. So you are going to be while you are performing that pre-processing techniques, which going to be understandable in terms of without losing the image information. And then one more important point is here, when you are concentrating on smoothing, it is possibly we will maintain without losing image information, but whereas sharpening, nothing but analogously, sharpening is a pre-processing technique that plays an important role for feature extraction in image processing. So what it will plays major role? It plays a major role in terms of feature extraction, sharpening, by using sharpening. Whereas in case of smoothing, what we understand that we are going to make intended for removing the possible image perturbations, so without losing the image information. That is happen at smoothing. Whereas at happening sharpening, we are concentrating on the major or important role for feature extracting in image processing. We are using is sharpening. Okay. So now let us we are going to be see one by another such a sharpening or and smoothing. How we are, let you see the sharpen. So you are sharpen the digital color images that takes the viewing conditions and human vision models into consideration is described. The method combines the Laplacian of Gaussian, that is we called as LOG operator, with spatial filters that approximate the contrast sensitivity functions of human visualization systems. So what you mean to understand here is, based on your selected sensor, based on your selected digital camera, here is digital camera is, we are going to say that it is nothing but a sensor. Okay, so such a digital camera sensor is right now concentrated on towards to possibly make in the terms of image smoothing and the sharpening based on the project which we are fulfilled here. one of the project actually. So this project we can also go to see in the internet, one of the citation I have given here, matlabsimulation.com. There how we are taking an image into, that is original image, is converting into smoothing, and it is converting into sharpening, and you are going to make for requirement of your originality. You see here, you can compare from original image how it is smoothing, from the original image how we make the sharpening. It is our original image. So sharpening how it is happen, smoothing how it is happen. Which one is best look? So smoothing is best look, because if we won't lose any information while you are intending the pre-image processing technique, which is we are concentrating at smoothing only. So that means sharpening means you can see here more or less almost good. But here how your censored image may going to be considered as original image, and it going to be applied smoothing pre-processing technique, as well as if you want to select the pre-processing technique, other one is a sharpening. That is depends upon your required application. That is depending upon your required application achievement. That is required application achievement. So that we are going to be considered here in terms of smoothing or sharpening application. So coming to the such as smoothing and sharpening, which we are concentrating is here in terms of pre-processing techniques only within the computer vision field. That is computer vision field. Computer vision. What do you mean computer vision field? Computer vision field is nothing but your image processing. Your image processing is right now concentrated in terms of pre-processing techniques, where computer vision field 100% obviously we are going to be used. There are the two pre-processing techniques. One is smoothing and second one is sharpening, which are we discussed in earlier slide also. So what does it mean to understand smoothing, which consists on the removal of possible image perturbations resulted from the image acquisition. Image acquisition is nothing but your camera image. Your camera captured image, which is we call as a image acquisition. Okay, that is what we are applying the smoothing. Whereas second one, which we are going to understand here, that is sharpening, is in charge of the improvement of the image visual appearance and the enhancement the details and the borders of the image, which we are going to be concentrating in terms of sharpening. So that means you are going to be understand image visual appearance improvement is in terms of applied by the sharpening pre-processing technique, which obviously help us in terms of enhancement of the details and the borders of the image only. So we can understand the major important point in between smoothing and sharpening. The distinguishing point is here you are going to be concentrate to improve your required image in terms of computer vision field only. So that means the smoothing and sharpening, that means where we can concentrate in terms of lot of smoothing and sharpening methods that are able to improve the visual quality of the images, without losing any image information. That means what we have to understand, if you are applying pre-processing technique as we call as sharpening technique or smoothing technique, which we are applied for the your image processing at the pre-processing level, so it won't lose any information. Meanwhile, it is help us towards to improve the your required manner of the visual quality of images. That is what we are going to be understanding here. And second point is, however, the same does not happen with the simulations approaches due to the opposite nature of these two operations. What do you mean to understand? These two pre-processing techniques are opposite nature of the operations. So that's what we are going to be applying in terms of your required process. So that means we can present a new model based on the graph theory that allows us to improve the details of the image at the same time that the noise is removed. So here one of the digital image processing which we are concentrating here is graph theory also. So mathematically how this graph theory help us in terms of improving, in terms of solving some of the image processing problems. Why? Because images we are considered in terms of matrix. This matrix is right now we are going to find in terms of your required process. So matrix is nothing but image. Well, how we may say image is a matrix? Because the image which contains the number of pixels basically from 0 to 255 pixels which are arranged in the form of matrix. You know the meaning of matrix is nothing but which contains the rows and columns of the values. Which are the rows and columns of the arrangement of pixel values is nothing but your image is in the form of matrix format. So once matrix format is there, then you can apply the mathematically towards to build or towards to develop a mathematical model which is considered under the graph theory, or which is we are applying the graph theory for the such a sharpening and smoothing pre-processing techniques. Okay, so that means you may be questioning here how this sharpening and smoothing may happen towards to get quality images, in the sense how it may be get quality images, in the sense we are here the more secret that a image which is acquired image from the camera, from the sensor, that image we are going to be keeping into the quality image process in terms of or by applying the smoothing and sharpening technique process, pre-processing techniques only. How that pre-processing techniques happen? If you visibly, how we maybe understand being an engineering student, being a technocraft, how we are going to be understand that in the sense we are the most secret is here we are applying in terms of smoothing and sharpening processes in terms of graph theory process. That means mathematically we are processing. We understand each and every pixels of the intensity values in the particular image values, where we are going to be changes in terms of neighborhood changes. Why? Because the matrix values which we are keeping in this matrix formation only. Coming to the basics of full color image smoothing and sharpening, how we may be understanding here in the sense, the color image sharpening is a set of technique whose purpose improvement of the image visualization appearance. That is very important here. So highlight or recover certain details of the image for conducting and suitable analysis of a human or a mission. So that means you can understand in terms of typical spatial filters for color image smoothing are based on the convolution of the image with different kernels depending on the intended result values only. So smoothing is always it will help in terms of intended result. So what we can understand from this slide, we are understanding that the full color image processing is by applying either smoothing or sharpening, we may obtain, for example, we concentrated on smoothing, then the convolution of the image with different kernels depending on the intended result, we may attain the image visual appearance in terms of 100% quality image. So what we can understand here, so applying smoothing, we will get your required quality of the visual image, visual appearance. So that means I am continuation here. So as far I was questioning that how the sharpening or smoothing can apply here in the terms of graph theory, nothing but mathematical way. So you are preparing mathematical model for the process of or for the understanding of how image values are, how image pixel values, how image pixel intensity values can be vary it, we are understanding in terms of consideration one of the image size, that is n by n, that usually we may assume 3 by 3, 3 by 3. According to this, using n is greater than 3 results in higher noise smoothing capability, but much more blurred images may appear. Along with this large increase in computational cost that make increasing the window not a good choice in general, not a good choice in general. So what we want to understand here is, here mathematically how we are applying kernels from the graph theory, from the, what is this? Graph theory. So graph theory will be help in the sense we are keeping the matrix image in terms of matrix, image in terms of matrix, that is m by n, where m by n, which we are consider here the size of the an image, which may going to be understand in terms of higher noise smoothing capability, but much more blurred images. So that we are going to be concentrate as a good choice in general for a smoothing and for a sharpening. So then there we are going to be remove the noise and making quality visible of the image, which can be achieved in terms of full color image in smoothing and sharpening. So coming to the such a process, how the graphically we can prepare such a process, how graphically we can prepare, how the mathematical models we can prepare, we can understand that the color models, we can understand the color models in smoothing and sharpening. How we are going to make, as I said, graph theory help us graph based model for color image processing. Here, as I said in the previous slide, where we consider the image in terms of number of pixels and that pixel intensity values are varies in terms of rows and columns, which consider m by n size of the image, which is right now we are keeping in terms of 3 by 3 sliding window of neighbors with the center on it. So that means each pixel is represented in terms of understand based on your selected objective function of f, which is varying at each values of I values. What is the I? Where I is equal to 1 to 3, so on, n values. Here the n value is nothing but, here this n value is nothing but, what we can understand is 3. 3 is nothing but 2 power of, what is this? So we are going to be understand this 3 is the size, that is 3 into 3. How much 3 into 3 will get? 9. 3 3s are 9 values. So each pixels of the capacity of your image, which represent in terms of RGB coordinates as F5 is equal to Ri. This is not F5, it is F suffix I. It is R suffix I. So what is the value which we are keeping here? This I values varies in terms of RGB Cartesian coordinates values. Why? Because your image is right now considered in terms of x comma y, where this f of x comma y is objective function. This is right now we are keeping in terms of color image. The meaning of color image is here RGB, color model. So the meaning of color model you are preparing in terms of sharpening and smoothing also possible based on your selected objective function. Previously we discussed about objective function of an image, how that help us to understand towards to keeping the pixels of the intensity in terms of neighborhood comparisons. So similarly, we are understanding here how the sharpening and the smoothing can be concentrated in terms of making the that basic image or original image towards to your achievement of quality visual image, that is human perception. Once we look at after prepared this sharpening or smoothing image, the human perception of the vision, that is in terms of computer vision, we may say that it is quality image, though it was removed noise. So previously it may be blurred image, now it is converted into your required form of image. So that is what we are concentrating here, the meaning of color models in the sharpening and smoothing. So in the continuation of this sharpening and smoothing in terms of color models, which is right now we are applying in terms of filtering process also. So spatial filtering process, 100% Cartesian coordinates will be help us. That is depends upon your applied kernel functions based on graph theory for the selected objective functions, which consists of kernel consists of all ones. This means that we only need our input image pixel values to compute new output values. That is the meaning. So that means we can just need to get the mean value of the pixel neighborhood and set it as the new output pixel value. That is also very important here. So that means you once you got the new output output pixel value, in the sense it is comparing the previously output values. So both will compare together. So we in aspect of visual image. So you may say after comparison in terms of color model smoothing, then you may say that quality. What is this called? Quality image. So the quality image how we get? So by applying the two of the techniques. One is smoothing and sharpening. So let us see the examples of color models in smoothing and sharpening. So before and after smoothing, let you see here, compare this one image with another image, how before and after image smoothing transformation. So which one is right now more quality, you can understand from these examples. So that means you are supposed to be understand 100% of smoothing transformation is gives to you in terms of your required quality analysis of the image. So that means even the number of pixels are varies in terms of rows and columns values, that each and every pixels of neighborhood comparison. How we are saying here, the previous slides of information which we are discussing here, there are 3 points we are applying here. Number one, your image is original image is here. Original. Number two, that we are going to apply in terms of your smoothing or sharpening. Smoothing or sharpening. Once this third point is, once this output of sharpening, which going to be get your quality image in terms of visual image perception. Understand? So that's what we can remember with this example, how we are making the original image as some blurred image or noised image can convert it into your required image, which is right now we can concentrate by applying the smoothing transformation. So with this, I am going to be close our discussion. What our topic on towards understanding this basics of full color image in smoothing and sharpening techniques application applied in terms of in the form of pre-processing technique. Okay, so that complete slides will help us for the understanding of some more details by referring this list of references. Okay, which are continually I am prescribing this two textbooks for the sake of understanding this color image processing. I am very thankful for your patient listen. Really, I am very happy to share with you all these details. Thank you so much for your patient listen. Thank you. So we will continue in coming slides also for the sake of understanding this subject image processing is other topics also. And thank you so much. Thank you. I hope you understood this complete slides of our discussion. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.